Welcome back. We're doing 3.4 right now. Here we are. Okay. So now we're talking about the slope-intercept form of the equation of a line. So now that we know what slope is, we're going to learn about the slope-intercept form. In the slope-intercept form, y equals mx plus b, m is your slope, b is your y-intercept, hence the term intercept, slope-intercept form. So, in this example, y equals 3x plus 4, the slope is 3, the intercept is 4, or 0, 4, because it's a point. In this one, y equals 1/2 x minus 5, the slope is 1/2, and the y-intercept is -5, or 0, -5. Characteristics are the intercept is isolated on the left side. It's y equal mx plus b. So b is always all at the very end. And then the slope is the coefficient of the x variable. All right. Find the slope and the y-intercept of the line. Okay, so m is 9. The y-intercept is 0, 4. M is -2/3. The y-intercept is 0, -2. Notice the minus on there. All right. The slope is 10. The y-intercept, since there's nothing there, is actually 0. Y equals 7. Well, in this case, the slope is 0, and the y-intercept is 7. 0, 7. Remember, I can write this as 0x plus 7. All right, what if your equation is not in slope-intercept form? How can you read the slope and the y-intercept? First, you put it into slope-intercept form. How do you do that? Solve for y. You've been solving for variables for a while now, so you can do this. All right. Now, personally, if you're given an option, if the equation is set up like 1, 3, and 4, your intercepts are better. It's much better to use intercepts because you can just cross out the 9, cross out the y, and find your intercepts. But they want you to practice solving for y. So I'm going to add 9x to both sides. First, slope-intercept, then find slope. Okay, I'm just trying to figure out what they want me to do. All right, so slope-intercept form is y equals 9x plus 5. The slope is 9, and the y-intercept is 0, 5. Number 2, I'm going to divide by 3. Y equals 2x. The slope is 2, and the y-intercept is 0, 0. Okay, here we're going to subtract 8x. Slope-intercept, y equals -8x plus 2. The slope is -8, and the intercept is 0, 2. All right, over here we're going to subtract 3x. 2y equals -3x plus 3. But we have to divide everything by 2 because that y has to be isolated. So now I have y equals -3/2 x plus 3/2. So my slope is -3/2. My y-intercept is 0, 3/2. All right. Now Graphing an equation. The easiest way to do this is to plot your intercept. So what's my intercept? 0, 1. Go away. Not you, the keyboard. Okay, so 0 in the x, 1 in the y. Plot the intercept. Count off the slope. Stop it. Did I somehow lose that? No. Okay. Why is it not letting me draw? Alright. There we are. M equals 3. Think of it this way. Okay, so that is a rise of 3. So it goes up 3, and it goes forwards 1, because they're both positive. So I just counted off. 1, 2, 1, 2, 3, forward 1. There we go. Now all I have to do is draw the line. And I'm good. I expect the line to extend the size of the graph fairly closely, not just barely through the points. I don't want some little dinky little line going from one point to the other. No, I want to see the whole line. That would be a line segment. All right, so plot your y-intercept, -2. Count off your slope, -2/3. So I can go up 2 and backwards 3 to get negative, or I could go down 2 and forwards 3. My choice. Since I'm in the negative numbers, I'm going to go up. So I'm going to go up 2, right? That takes me to there, and then I go back 1, 2, 3. So that's here. Okay. Now you can keep counting them off. Up 2, boop, over 3, 1, 2, 3. Up 2 over 3. Just to give yourself more lines to point if you're freehanding the graph. Okay, so again, I want to see the full line, not just a little bitsy bit of it. Okay, if I subtract the 2x, so my slope is -2, the y-intercept is 0, 0. So I plot the 0, 0, and then I count off the slope. -2 in the y direction. 1, 2. That's downwards 2. Positive 1, so I go forward 1. Well, that's a really horrible circle. It's not plotted well. Let's try that again. There we go. That's a little better. Alright, so I kind of count off as I eyeball this as I go through. So I can see 1, 2, 1, 2. I can double check myself. Yes, it's a negative slope. As I read this left to right, it's falling. So it definitely should be a negative slope, which it is. All right, we have another one. We subtract 7x from both sides. We divide by 2. So y is equal to -7 over 2x plus 7. All right, my y-intercept is 7, so I go up on the y-axis and I put a dot right at 7. It's all the way at the top. My slope is -7/2. So I'm going to go down. So I go down 7. Whoa, that's all the way down here. Forward 2. Okay, and then down 7 and forward 2. So I've got 3 points here. Makes life a little easier for drawing it. Yeah, okay, so I'm not super straight. All right. Number 5. We're going to divide both sides by 4 because we've got to get that y isolated. So y is equal to 5/4 x, which means my slope is 5/4, but my y-intercept, since it's a 0, is the origin. And I count, it's positive, so I count up 5, 1, 2, 3, 4, 5, forward 4, 1, 2, 3, 4. Or I can count down 5, 1, 2, 3, 4, 5, and backwards 4, 1, 2, 4. Notice that's making a straight line through the x, through the origin, sorry. There we go. Can you tell from the equation if two lines are parallel? Well, first off, if you put them in y-intercept, yes, because they'll have identical slopes. In this case, I can look at this and I can say, all right, if I divide through by 3, I'm going to get x minus 3y equals 6. And the other one is this. Oh, that's a 9, sorry, not a 3. Okay. Now these are going to be parallel because your slope is a combination of the coefficients of the x and the y. Since my x and y have identical coefficients, the slopes will be identical. Okay, so we'll see that by solving for y. So this is minus 3y equals minus x plus 6. Divide everything by negative 3. Y equals 1/3 x plus, minus 2. So 1/3. Now if I do that with this one, I subtract the x, minus 3y equals negative x plus 9. Divide by 3, negative 3. Y, no negative, sorry about that. Okay, y is equal to, the negatives again will cross off, so I have 1/3 x minus 3. So different y-intercepts, same slope. So yes, these would be parallel. Alright, so we have this equation. Minus 2 is my y-intercept. Count off a slope of a rise of 1 and a run of 3. Up 1 over 3, up 1 over 3. Down 1, backwards 3, down 1, backwards 3. Down 1, backwards 3. So I'm going to, So I'm going to go through all these points. Alright, the other one has a y-intercept of negative 3, but still has the up 1 over 3, up 1 over 3, up 1 over 3, backwards 1, down 1, backwards 3, down 1, backwards 3, down 1, backwards 3. See, I'm just following the bad points. There we go. Okay, so you can see that these are indeed, if I could draw truly straight lines, parallel. Okay. And we're done. All right, good job. Go do your homework. All righty, bye-bye.